So broadcast domain and collision domain. um, so what are those, and why do we what's the importance of those, those two terminology. So many years ago, networks consisted of repeaters, bridges, and router. So repeaters were, they just used to basically copy or repeat the same thing that a device would send. Bridges were like, basically you can think of it as a dumb version of switches that we have today, and router, the routers that we have today. So switches are the successors of the bridges. They're better. So a switch is nothing else than a multi-port bridge, and a traditional switch doesn't know how to pass traffic to a different broadcast domains or VLANs. Passing traffic between different broadcast domains is a job for a router, and a router has an IP interface in each broadcast domain. So make a note of that. So a router, right, has an IP interface in each broadcast domain. An IP interface is used by the clients in the broadcast domain as a gateway. So what I'm trying to explain here is, select the pencil. Okay, so this is the broadcast domain, right? This entire thing. So that means why is that the broadcast domain? Because there's a router here. Let me select red. This is a broadcast domain because of there's a router, right? So that means all the traffic in here in this diagram, right? So we have a first of all, let me explain the diagram to you. So we have a computer, right? So end device, so a client device, a PC, printer, whatever you have, right? A smart TV, computer, laptop, phone, that would be the end device. So that's these computers. Then we have a layer 2 switch. That's a very important to note, right? That's a layer 2 switch. So it only has VLANs on there, so it doesn't do any routing, right? So if it were to do a routing, that would be layer 3. And if this was a layer 3 switch, then the broadcast domain would be this. Let me change that to blue, change the marker to it. Okay, so this would be the broadcast domain if this was a layer 3 switch right here, right? So if this did routing, then this would be the broadcast domain. Okay, this is just a repeater, right? So you can actually just ignore this. What it does is just repeats the signal, like whatever this gets, this switch forwards, this will just forward all that packets out of its interface, and then right, and that packet will go to the router because that's the default gateway if they're trying to talk to internet. And then okay, yeah, that's why when you see a default gateway, right, in a topology, that from there to the layer 2, all that stuff that comes in a broadcast domain. So just think about that term, right? The broadcast domain, it broadcasts all the packets, right? So let's say if this PC makes an ARP request, this PC were to make an ARP request to this switch, for, let's say it's trying to get ping google.com, well, so what's this PC gonna, or not, scratch that. Let's say this PC is trying to ping 8.8.8.8 IP address, which is a Google public IP address. So what this PC is gonna do is it's going to send out, it's gonna be like, you know, an ARP request, like where is I8.8.8, is that on the network? No. Okay, so it's gonna be, so this switch is just going to forward that packet straight to the router, because, you know, it's not on the network. And that's why that's the broadcast domain, because if it does do a broadcast, right, for ARP, that's what I was trying to get to before. Like if there is something is on the network and it's like I said, it's trying to ping that this PC, this IP address, this VLAN, this switch is gonna broadcast to all, out of all its ports. That's if it's on the same VLAN, right, like same local area network. Okay, so now what's a collision domain, right? There's a difference. So a collision domain is a scenario in which when a device sends out a message to the network, all of the devices which are included in its collision domain have to pay attention to it, no matter if it was destined for them or not. This causes a problem because in a situation where two devices send out their messages simultaneously, a collision will occur, leading them to wait and retransmit their respective messages one at a time. So remember, it happens only in case of a half duplex mode. So as I said, right, this is a repeater, so anything, like let's say this PC tries talking to this PC, but at the same time this PC also sends a request to talk to this PC, right? You see they're gonna collide right here in this device, and that's why that's a collision domain right there. In fact, this is also a collision domain right here. So not the entire switch, just let me make it better. If it's a switch, that means every single port that connects to the switch is a collision domain. So when we say, when they circle this one, right, this diagram, it's not like the PC itself, it's actually the port itself that's the collision domain. But you know, so you want to include the device as well, so that's why the link and the port. So mainly the port on the switch is the collision domain, and this port, so let's say if this was port 2 and this is port 3, right? Port 2, it is its own collision domain, and port 3 is its own collision domain. And same thing with you know, this link is a collision domain, this entire thing would be a collision domain, and then this would be a collision domain because it's, you know, there is one port on switch. This is a mess that I made with the painting, but let me erase that. So hopefully you're clear on the collision domain now. Right, basically if it's a switch every single port on the switch is a collision domain. If it's a repeater, everything connected to that's one collision domain, and if it's a router, that link and device is connected on the other side is in that same collision domain. And then let me also talk about the broadcast domain again, like just give you a brief description. So a broadcast domain is a scenario in which when a device sends out a broadcast message, all the devices present in its broadcast domain have to pay attention to it. This creates a lot of congestion in the network, commonly called LAN congestion, right? So it which affects the bandwidth of the users present in that network. From this we can realize that more the number of collision domains and the more the number of broadcast domains, the more efficient is the network, providing better bandwidth to all the users. So what does that mean is like the since so let's say if this is a 48 port switch, right, that means we have 48 broadcast domain, which is good, right? Because they're all their own they're every single port is its own broadcast domain, so that doesn't create a LAN congestion, right? If this was a repeater, then this creates LAN congestion because all the traffics, they're all like meshed in together, but every single port, right, they know exactly how to forward the traffic, and that doesn't create LAN or like local area network congestion. So which of our network devices break collision domains and which of them break broadcast domains? So let's say if we have a hub, let me use this stuff. So if we have a hub, right, we start with the so a hub is neither a collision domain separator nor a broadcast domain separator. Also, all the devices connected to a hub are in a single collision and a single broadcast domain. So, because remember, hubs don't segment a network, they just connect network segments together. But a switch, every port on the switch is different collision domain. So messages that come from devices connected to a different port never experience a collision. Right, because if you think about like a lane, a port is a bus lane or a highway. If there is a traffic going there, it's not gonna collide with another highway because they're their own different highways. Yeah, so hopefully this clear all that stuff up. So that's the broadcast domain. Is basically, think of it as when you have a default gateway, everything underneath that falls into the broadcast domain. So the LAN, VLAN, all that other stuff. And then the collision domain would be, if you have a regular switch, then all the ports connected to that switch are its own collision domain. if you have a hub, right, or or a breach, or something like this, then that would be its own, the entire thing, like everything connected to that X has one, that would be its own collision domain. And then this router, this link would be the, that's its own collision domain. Same thing with this one. So I think technically over here we have, let me select red, we have 1, 2, 3, 4, and then 5 collision domain, right? And then the broadcast domain would be this entire thing. So thanks for watching. Let me know if you guys have any questions, and I'll help you answer them. And let me know if I made any. I think I did made a few mistakes while doing this explanation, but I did try to solve it and correct myself. So let me know if you find any other mistakes, and I'll have them corrected in the comments below. Alright, take care guys.